this is about phase shift. We start with a function y equals a sine omega x plus phi. That's the Greek letter phi. This will be make a phase shift. It'll move the wave left to right. So first, let's pull out a factor of omega from both these terms. Omega times x plus phi over omega. Rewrite that again as a sine omega of x minus negative phi over omega. Who just came? Oh, Preston. Okay, I'll make a note. Right. All right, now, period, amplitude is absolute value of A. Period is 2 pi over, well, absolute value of omega. And this minus delays it by negative phi over omega. So the graph is shifted horizontally by negative phi over omega. That's called the phase shift. And similarly, if instead of a sine, it'd be cosine, a cosine omega x plus phi. Same numbers though. The amplitude will be the absolute value of A. The period would be 2 pi over the absolute value of omega. And it's shifted left to right by negative phi over omega. Now, there are some shortcuts, which in fact I use on this, and you may too. If we have sine of omega x plus or minus 2 pi, or cosine of omega x plus or minus 2 pi, that just gets it back to where you were. That's period 2 pi. If you had a phase shift of pi, sine of omega x plus or minus pi, well, if this plus pi in here, that turns a sine to a minus sine, a cosine to a minus cosine. I call that the half period of pi. And if you have a sine of something plus or pi over 2, that turns a sine into a cosine of omega x. And if going backwards, of cosine omega x minus pi over 2, that turns into a sine of omega x. But if you have a sine of omega x minus pi over 2, then it'll be the opposite of cosine omega x, because these two differ by pi radians, and therefore a half period, and therefore minus. And similarly, here cosine omega x minus pi over 2 is sine, then plus pi over 2, cosine omega x plus pi over 2. These differ by phase of phi, which makes it a positive sign, flips it over. So it's a pi halves phase shift between cosine and sine. And yeah, it can be a little hard to keep track of, is it plus or minus cosine, minus or plus sine? Okay, here we go, some examples. Okay, here, y equals 4 sine 2x minus pi. Well, this minus pi, oh dear, I did it again. This should be a minus. Oh dear, honk again. 2, 5, 2, 6, page 3, minus 4 sine 2x. Oh dear. So this should be a minus 4 sine 2x. And so the graph will be upside down from this, and I have to change that. My apologies. Okay, here y equals 2 cosine 3x plus pi over 2. Cosine of something plus pi over 2 makes a minus sign. Oh my God, did I make another mistake? I did make another mistake. Oh, right. Well, all right, let's put it this way. It's all right. It's all right. We can write this as 3 of x, 2 cosine 3 times x minus negative pi over 6. Amplitude is 2. Period is 2 pi over 3. Phase shift is negative pi over 6. So, since the phase shift is negative pi over 6, I make the table starting at negative pi over 6. At that value, you get cosine of 0, which is 1 times 2 makes it 2. And all right, so one full period later, pi over 6 plus 2/3, which if you did the math, do the arithmetic, is pi over 2. We're back to 2. Halfway between the two peaks is at negative pi, halfway between these two at pi over 6. It's going to be negative 2, and halfway between the peaks and the values of the zeros, which are at 0 and at pi over 3. So minus pi over 6 by 2, 0 by 0, pi over 6 by negative 2, pi over 3 by 0, pi over 2 times by 2. And the book asks to do 2 waves, so here's 2 waves of it. And and this is a minus of sine of etc. So it really is upside down from sine. Here we have y equals minus 3 sine 2x plus pi over 2. Now let's make sure I got that right. Yes, sine of an angle plus pi over 2 is cosine of the angle. So this minus, so this pi over 2 turns the sine into a cosine. So if y equals minus 3 cosine 2x, the amplitude is absolute value of -3, which is positive 3. The period is 2 pi over 2, which is pi. So all right. At 0, cosine 0, which is 1 times -3 is a -3. 1 full period later at pi, it's back to -3. Halfway between, it's at a value 3. And halfway between the peak and the values are the zeros. Halfway between here and here is pi over 4. Halfway between here is 3 pi over 4. So 0 by -3, like here. Pi over 4 by 0, like here. Pi halves by 3, like here. 3 pi over 4 by 0, here. Pi by -3, here. And here are 2 waves of it. All right. Here's graphing y equals -3 sine of -2x plus pi over 2. Now, all right. Sine of angle plus pi over 2 is cosine of that angle. And cosine of a minus an angle cancels it out because cosine is an even function. So you get -3 cosine 2x. Oh, and by golly, that's the same as this one here. So you get the exact same graph. -3 to 0 to pi halves by 3 to 0 to pi by -3, and continuing on the cycle. Now here they ask for a reverse problem. Write the equation of a sine function with amplitude 3, period 2 pi, and phase shift -1/3. So y equals a sine omega times x minus -pi over 2. This should be a plus, shouldn't it? All right, this should be a plus. 7 x plus 5 over omega. Okay, I have 3 corrections to make in the notes. All right, absolute value of a is the amplitude of 3. So a, well, strictly it's plus or minus 3, and we really have to determine that later. Period is 3 pi, so 2 pi over omega equals 3 pi, which makes omega equal 2/3. And the phase shift is -1/3. So this should be a minus. All right. So you get, and all right. The sine function we say is it starts going up, so a positive value of a, and and it says it's a sine function. So I'll make this the +3 here, 2/3 here, and this should be x. Actually, +1/3 works fine. +1/3 works fine because it does move it to the left 1/3. So here we go. Y equals 3 sine of 2/3 of x plus 1/3. But I really should rewrite this as a plus. All right, so there we are. Okay, I think that'll do for now.